what will happen if the magnetic field is uniform. So this is a review of how to get the force on a wire. The wire could have a certain length, and in a non-uniform magnetic field, in general, the force, you have to sum I delta S cross B over all the wire, and if you write it as an integral, it's integration of I ds cross B. B in general is different for different elements of the wire, and delta S also changes from element to element. So what happens if the magnetic field is uniform? If the magnetic field is all the same everywhere, pointing in one direction, then in that case, in the summation, the BI is not being summed over anymore, because B is the same here, it's the same here, it's the same here, it's the same here, it's the same everywhere. I is a constant, it can go out of the summation. So the only thing that's being summed is this, delta SI. So this limit of sums, you're basically adding this vector plus 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 this vector. When you add all these vectors, what do you get? You get one vector that starts from the beginning and ends at the end. So we can replace this limit of sums by this vector L prime, which starts over at the beginning of the wire and ends at the end, the last point. And then we get a simplified rule for the force on the wire, which is I L prime cross B. And this only applies when the magnetic field is uniform. L prime is the vector that starts at the beginning of the wire and ends at the end of the wire in the direction of the current.